Okay, sixth graders, today we're going to be looking at finding a pattern in sequences.
Is this gonna make a match, Mama?
By the end of this lesson,
Mommy?
you will be able to find a pattern to complete a sequence using a function table. So let's look at some vocabulary. A sequence is an ordered list of numbers. A term is a number in a sequence, also the output, if you refer back to what we were talking about before with functions. A term number is the location of the number in a sequence, which is the input. Okay. And then there's two different types of sequences that we're going to be looking at. One's an arithmetic or an arithmetic sequence.
I got those ones match and those ones match.
Which is a sequence with a common
now bunnies doing match.
difference between each term. Basically, it means you're going to see addition or subtraction between your terms. And a geometric sequence is a sequence in which each term
is Mama.
multiplied by the same amount.
I got one of it.
So now let's look. Is this a sequence, an arithmetic, arithmetic, or a geometric sequence? And how do you know? And what is y when n equals 5? So if you look here at our term numbers, we have 1, 2, 3, 4, 5. And then here we have 2, 4, 6, 8. So if we look at our terms and we're looking at the sequence we see there, we see that each increases by 2. Since it's a plus 2 in between terms, we know that this is an arithmetic sequence. And if we continued our pattern, 8 plus 2 would be 10.
Okay, we got one bunny, one.
Now they're also going to start asking for function rules. A function rule is an equation that describes the relationship between the input and output of a function, or the term number and the term. It's kind of like the shortcut. So we're going to write a function rule that describes each sequence. So basically what we're doing is we want to look at what can I do to x to get our y.
I did it, Mama.
So let's look at our first example. With 1, we could say 1 plus 2 is 3. But if we did that, we'd have to check, is 2 plus 2 equal to 6? It's not. So we know that plus 2 is not our rule. So what's something else that we can do to 1 that we would get 3? Well, we could possibly multiply by 3. If I go to my second term and multiply by 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. So our times 3 would work out. So in this case, our y is going to equal 3 times our x, or 3x, because remember that's how we write multiplication. So I'm going to go ahead and pause the video and try the next one on your own. Okay, so let's look. So from 1 to 4, I could add 3, or I could multiply by 4. When we look at 2, if I do 2 plus 3, or 2 times 4, which one is the one that actually matches up with what we're asking? Well, it would be the plus 3 in each one. So our rule is going to be y, or our output, equals our x plus 3. So now let's look at a real life example. Sarah is 1 week to read a book. She plans to increase the number of chapters she reads each day. Her plan is to read 3 chapters on Sunday, 5 on Monday, 7 on Tuesday, and 9 on Wednesday. We want to write a function rule that describes the sequence and predict how many chapters Sarah will read on Saturday. So if we try to make a table just to organize our data, so x would be our day, and y would be the number of chapters.
I did it.
Okay, so on Sunday,
I did it, Mama.
which is day 1, she's going to read 3 chapters. On Monday, which is day 2, she's going to read 5. On Tuesday, which is day 3, she's going to read 7. And on Wednesday, which would be day 4, she's going to read 9. Now, if this was simply a matter of seeing how many days how many chapters she reads on Saturday, we could just continue our pattern and go Thursday, Friday,
Wednesday.
Saturday, which would be days 5, 6, and 7, and look at our pattern here, in which case we see that each one is increasing by 2. But because they're asking us to write a function rule, we have to look at what's happening between x to get to y. So why don't you go ahead and pause the video and see if you can figure out the function rule for this pattern. Now this one's a little bit different. On the previous ones we had one step because we could simply go, okay, well, we either try 1 plus 2 or do 1 times 3. Well, in this case, if we do 1 plus 2, that would equal 3. But if I do 2 plus 2, that would equal 4 and not 5. So we know that plus 2 can't work. Well, at the same time, if I do 1 times 3, that's 3. But if I do 2 times 3, that would be 6, which also doesn't work. And that's where looking at the common difference over here, which is plus 2, can help. When we're looking at that, the common difference is often multiplied by our number here. So if we look, we notice that we could do 1 times 2, which would be 2, plus 1 would be 3. 2 times 2 would be 4, plus 1 would be 5. 3 times 2 would be 6, plus 1 would be 7. 4 times 2 would be 8, plus 1 would be 9. So our y, or our output, is equal to 2 times x plus 1. And since Saturday is day 7, we can say y is equal to 2 times 7 plus 1,
Can I color on the back?
which is 14 plus 1,
Can I color
or
on my
15
back?
chapters.
Okay.
So the biggest thing here is just be aware that it's not always just a single operation that we can find between our input and output.